Hi, welcome back to McClatchy Maths. My name is Natalie McClatchy and today I'm taking you through our 6th video in our matrices series on the determinant of a matrix, and it's aimed at our specialist students across Australia. In this video you're going to find out the purpose of a determinant. We're going to do some worked examples using 2x2 and 3x3 matrices, and then I'm going to take you through how to do this on the Casio calculator. And I'd like to shout out to our existing and all of our new subscribers. There are so many, too many to count. I'd like to say thank you so much, all of you, for joining me here at the channel and for your ongoing love and support and encouragement. If you see something today that you found helpful, why not like the video, subscribe to the channel and hit the notifications button, and that way you'll know whenever a new video is being posted. Alternatively, you can follow us on McClatchy Maths or on Facebook. Usually we've got a lot of our teacher community is on Facebook and a lot of our students on Instagram following McClatchy Maths there. It's a great way to get in touch as well if you've got any questions or concerns. Okay, let's kick off and find out what the determinant of a matrix is. Well, it's a special number that is calculated from a square matrix. So that's very important to note. It's a square matrix with the same number of rows and the same number of columns. It's used to help solve linear equations down the track, and you'll see that in our upcoming videos. It also gives us important information about our matrix for some analysis. And so we just express this determinant of a matrix in 3 different ways that we can communicate that. We can either say det, D-E-T, and then brackets, matrix A, or we can simply do a triangle. That's one of my favorites because it's quick and easy. Or we could put the A inside 2 straight brackets, a bit like absolute value. And that's how we express that we've found a determinant. So let's have a look and see how to find it on a 2x2 matrix. So we're going to actually give every element in our matrix a letter, A, B, C, and D. And we've got a formula here to find the determinant from that matrix. It's simply A multiplied by D, there on the leading diagonal, and B multiplied by C, and you subtract 1 from the other. This is actually, if you're in Queensland, on your QCAA formula sheet, so you don't need to memorise that. But you do need to know which one is A, which one's B, C, and which one's D. Okay, let's do that with a worked example now. We're going to find the determinant of this matrix A. So I write my formula, always a good idea to do that first. Then I substitute into the formula, 3 times 5 take away 4 times 6. And then I work out the difference. 15 take away 24 gives me -9. It's that simple. You're going to love 2x2 matrices and finding the determinant. Very easy. Determinant of a 3x3 matrix, however, not so easy. It's a bit more complex. Now, in our syllabus in Queensland, you don't have to know how to do this algebraically. It's not in our syllabus, so we're going to do that on the calculator later on in the video. But it's always a good idea to know where that comes from. So we're going to do that using technology, but let's have a look and see how to do that. It is quite complex. You're going to really appreciate your calculator after this demonstration. So once again, we've got this matrix A. We've got some extra elements now. We've got A, B, C, D, E, F, G, H, and I. So the placement, once again, very important. Now, we're going to break that down into 3 2x2 matrices. You might be thinking, well, how does that go? I've got 9 elements. And so what you're telling me is I'm going to get 4, 8, 12 elements out of 9. How on earth does that work? I'm going to show you. So what we're actually going to do is we're going to cross out that first row and make some matrices out of the 2 bottom rows. And we call those, row 1 is going to be the coefficient of each of those minors. Let me show you what that looks like. So matrix A is going to get broken down now into 3 subdeterminants or minors. So we cross out that first row. And then we're going to cross out the first column, A, D, and G. What is left over goes inside the brackets for our first minor. And the coefficient of A, which is the column, the first one that's got the double cross on it, it becomes the coefficient of that first minor. Now, if you can follow the pattern, it's really not that hard. Now, B has a negative number in front of it. It's going to be a second minor has the coefficient of B becomes negative, and we cross over the second column this time, and what's left over goes inside the set of brackets. And then our third minor, we move that crossing out column across 1, and C is double crossed, so it becomes our coefficient. And it's positive this time. Now you'll notice that the brackets are straight up and down brackets, not the brackets that sort of curve like that. That's important to note because it's a determinant, not necessarily a straightforward matrix. So we give that different notation. Okay, so we can bring that together now into one not so simple formula. Let's see how that works using some numbers now. Okay, so I've got the formula, and then I'm going to bring some numbers in my second worked example. It's a simple case of substitution, not anything particularly hard there when you're substituting. However, you've just got to know what's what in the formula. Okay, so now we're going to actually use each of our minors. We're going to find the determinant of each of those minors using our original determinant formula AD minus BC. So it's tempting to think that we're just going to be performing scalar multiplication, but that's not the case here because it's not a normal matrix. It's a determinant with the brackets. So we need to make sure we're doing the right process, AD minus BC for each one. So let's do that. So we've got 9 times 7, take away 2 times 1 goes in the first set of brackets, which is the determinant of that first minor. In the second set of brackets, we've got that leading diagonal again, 3 times 7, take away 2 times 8. And in our third set of brackets, when we're working out our third determinant, which is our third minor, 3 times 1 is our leading diagonal, take away 9 times 8. And we're going to simplify that a little bit further, and then further again, and then finally, we get the determinant is negative 129. Now that's all fairly tedious and time consuming. I'm sure you're wishing you knew how to do that on a calculator. So we're going to do that now on the CG50. We know we're looking for that determinant of negative 129. Let's get there and do it. Okay, so we are here in our Casio CG50 and we've got our opening menu. We actually want to get into the matrix menu. It's very tempting to look for that menu 1 there, but that's not where we're going. We're firstly going to press the F3 button for our view window and press execute. And that gives us a blank screen. Now where we actually want to be here is on our Math/VCT menu. So let's click that one there and it brings up some matrices. Now I'm going to clear my previous matrices by pressing delete all and then F1 button, and it gives me a clear screen to start with. Now the next thing I want to do is press my execute button, and it will bring up this particular screen here that you can see, which tells the computer or the calculator what kind of matrix I'm wanting to build. I'm wanting to build a 3 by 3. So let's type in 3 and press enter, and 3 again, press enter. And then if I press execute, it's now got the matrix on the screen and I can enter the information. Now when I do this, I actually need to press the enter button. Even if I've got zeros, I still need to press enter, otherwise it's not going to recognize it. So let's type in what we've got. 5, 4, 6, press enter again, it brings us down to the next row, 3, 9 and 2, and then 8, 1, 7. Okay, so now I've got my matrix all entered. Now it's time to find the determinant. So what I'm going to do firstly is exit out of this menu. Don't panic, it's still got it sitting in the background. You're also going to want to exit out of here as well and come back to this main menu. Now I'm going to choose option and then choose MAT/VCT. That's where I want to be going. And you can see the list along here is DET, determinant. And then I want to tell it that I'm looking for the determinant of matrix A, because I might have multiple matrices stored in the background. So I'm going to click on the Mat button, and then I'm going to press Shift and choose this one here with the X theta T, because that's my little letter A, because I'm looking for the alpha and then A. And then I press execute and I get negative 129. You're going to need to want to write down that process and memorize it. It is a little bit more complex than, say, the old ClassPad was. There's quite a few menus you do need to go through to find that determinant. It isn't all in one space. So maybe rewind and record what we've done. Well, let's have a quick chat about what's coming up next in this series. We've got inverses to cover. We're going to look at some matrix equations, transformations, and I'm going to continue interspersing those videos with some of our Queensland's 2020 General Maths Paper 2 Unpacked. So if you're in General Maths, that's for you, and specialist students, these ones coming up are for you as well. I'd like to say a big thank you to everybody for watching today's video. If you have any questions, you can contact me at mcclutchymaths@yahoo.com. You've been watching McClutchy Maths. My name is Natalie McClutchy. Have a wonderful day.